Okay, so this is similar to my MATLAB functions audio DSP effects tutorial. I'll just show you the same effects but implemented using Simulink block diagrams. So I've combined them all together into one block diagram just for ease of use. I'm just going to play the original sample of audio first. Okay, so it's just an acoustic guitar strumming. So I'm going to flick this switch here, which turns on the effects processor. So nothing is switched on at the moment, so this will give 0 output. So I'm going to show you the distorted function first. So basically it's made into its own subsystem. So to expand this, show you what's inside. So it basically works as a clipping value, as I've shown you in the functions video. So to do this, I've used the saturation block in Simulink, which will give a distorted sound. Now, I'll show you the difference in sound now. So yeah, doesn't sound great distorting an acoustic guitar, but anyways, I'll show you the delay effect now, which is basically a decaying echo. I'll just expand the subsystem so you can see the blocks inside. So here we can see all these values, but all the parameters for these effects have been fixed. Just for ease of use for this tutorial, you can see that there's two delay blocks in here. The first one adds a delay of 10,000 samples, so roughly 250 milliseconds. The original audio is sampled at 44.1 kilohertz. So this adds a delay of 10,000 samples and applies a gain of 0.4 to it and adds it to the summing block. And here we see an identical delay with a higher gain applied to it, and it's actually subtracted, which gives it more of a decaying effect. It's more effective than the functions version we saw in the last video. So I'll play that back. So you can kind of hear that decaying echo in the background there. Now the next function to show is the tremolo effect. So this is basic amplitude modulation. So I'll expand this system here. So I referenced a sine wave for the amplitude modulation, and as the audio file here comes in frames of 1024 samples, I had to unbuffer the frame so it comes in one sample at a time into here, and given its sine value here, and multiply it together to give the amplitude modulation. And this buffers it back to 1024 samples. So I'll turn that effect on now. So that's the tremolo effect. Now this is a low pass filter effect applied with the cutoff frequency of 500 Hz. So the exact same coefficients calculated in the MATLAB audio DSP functions tutorial were used for this. I'll just show you the subsystem. So it's just using one block basically. And you can see the coefficients here. So this should muffle the sound quite a bit. So that was very noticeable. It cut off all frequencies above 500 Hz, and there was a lot of higher frequencies in that acoustic guitar playing. Now the next effect to show is the flanger effect. So this is a variable delay effect. And I'll just show you the inside of the subsystem. So again, it references a sine wave and uses a variable integer delay block. And again, these unbuffer and buffer blocks need to be used so that each sample can be given its own sine value. Let's turn on this effect. So you could hear the kind of sweeping effect in the background there. So as these effects are all together, you can actually combine them in a chain. So I'll just show an example of that. So the flanger is already on.